Okay, so if we want to do our MATLAB translation for step A, so step A is to generate our vector of time values. What should we write here for MATLAB translation?
Linspace.
Linspace. What else could we use? Colon operator. Does it matter? No, right? We can pick whatever's your favorite. Everybody seems to like linspace, which takes more typing than colon operator. So, you know, just the same as everybody likes scripts instead of functions, but I think scripts take more work than functions do, but that's perfectly up to you. I do the same thing. It's just a universal truth. All right, so we're going to use linspace to do task A. What about task B? Do we need to do anything special for that? Just define the variables, right? So usually when I get to this step and I do my MATLAB translation, I just kind of like to list out which variables I'm going to be creating. So I've got A, B, C, D, and M. And then I like to remind myself if all of these variables are going to be scalars or vectors. Are they going to be scalars or vectors? Vectors. What about for A? We forgot to do that. Is linspace going to give me a scalar or vector? Vector. And what's that vector from step A going to look like? What is T? If I draw a picture of T, is it going to be a row vector or a column vector that comes out of linspace? A row vector, right? So when I'm doing my MATLAB translation, a lot of times I like to draw myself like a picture of my vectors that I have, and maybe put some fake values in there just to kind of get my brain going on what's going to be in there. So we said -5, I don't know, 0, 5, 10, 16. So we got 5 values in our T vector for now. What about A, B, C, and D, and M? What are they going to look like? So if I just write A, I can set them up however I want, right? They could be row vectors, they could be column vectors. We don't say what they are. Doesn't really matter. But they're all going to have how many values in them? 3, and those are for each of our 3 rockets, right? So A, we have 10, 10, and 12. So an important thing to think about when we get to nested for loops is what things do we have changing in this problem? How many things do we have changing in this problem? Yep. The T. So time is changing. We're going to have a bunch of different time values. What else is changing? The rockets are changing. So we're going to have to calculate the velocity of the first rocket over a bunch of different time values, then the velocity of the second rocket over a bunch of different time values, then the velocity of the third rocket over a bunch of different time values. So we have 2 different things that are changing in this problem. We have the time that's changing, and we have the rocket that's changing in this problem. So we got to think about that. We got to think, okay, we got 3 rockets, and we have a bunch of time values. I said you can pick the number of values, right? So in this case, I put 5 up here. We probably want more than 5 for actually writing our MATLAB code. All right? So we get 2 things changing in this problem. So we get to step C of our MATLAB translation. What does this say? Step C says for each rocket and each value of T, calculate the velocity V given the information above. So what do I need to do this? Equation. So I've got my velocity equation up at the top, right? Am I going to be able to write that velocity equation just how it is, or do I need something to help me write that velocity equation? Some kind of MATLAB code. We need if statements, right? Because we've got the velocity equation changes depending on the time. So we've got to have an if statement to help us calculate the velocity one way, and then another way, and then another way, right? If statements help us make those decisions. We can pick this path or that path or that path, and so that's what the if statement's job is, right? So we go to C, and we say, all right, I think, first off, I know I'm going to need an if statement, right? I'm not going to worry about the loops yet. I'm just going to worry about my if statements. If I'm going to write my if statements, what might they look like? So I'll kind of start about over here somewhere, and I'll say if, and what's my first if statement gonna say? If we assume, let's just assume that we have one rocket and one time value. How would we write these if statements? So those are both scalar values for right now. T is greater than or equal to 0.
And T is less than or equal to.
Okay. And then what do we put inside here? We put our velocity equation, right? Say v is equal to a times t squared minus b times t. What's next? Else if. Should I put a space here? No, right? I need to squish those words together. MATLAB likes them to be one word. No space there. Else if, and what's my expression?
T greater than M.
T is greater than M.
And T less than or equal to 60.
Okay. And then I put my velocity equation here. V is equal to C minus D times T, right? Now what do I need?
Else.
An else? What expression do I put over here?
We don't need it.
Nothing, right? We don't put anything over there. And then what do I put inside of my else statement? V equals to 0. Anything else?
And
We need an end. All right, so now we've written our if statements and our else if and our else statements if we have one t value and we have one rocket. Well, unfortunately, we don't just have one t value and one rocket. Told we have a bunch of different things. We got all these different things changing at one time, right? So let's figure out kind of one layer up in complexity. If we have, let's see, a whole bunch of t values. So we go back and we say we have our vector t values, but we still only have one rocket. What kind of thing are we going to need to help us change the time values? The for loop. And why do we need a for loop? Because it repeats. Why can't we use a while loop? While loops repeat.
no,
We don't have a way to get out, right? That's the one thing we have to know about while loops. What's the nice thing about a for loop when we have a vector like this? Why do we use for loops with a vector like that? Yep.
To calculate like the first number with the first case, then the second one, it will give you the final answer as a vector.
Well, if you set it up right, it'll give you the final answer as a vector, right?
Yeah.
So what for loops help us do when we have vectors like this is pull out one number from our vector at a time. So we can go through and we can say, pull out -5, then do all this stuff, calculate our velocity. Pull out 0, then go through and do all this stuff for the velocity, right? So it lets us repeat over all of our different time values we have, one repetition per time value. If we used a while loop, we could possibly get it to work, but it's not as easy to set it up. So for loops are really the thing that we can use when we've got repetition like this, where we've got a bunch of different values that are in a vector, and we need to do something with each one. Why can't I just take my t vector and stick it in these if statements as I have them written now? What's wrong with that? Yep, Tark.
The MATLAB get us like which value I'm gonna like which one gonna fit
Right, so if I tell MATLAB, if I leave my MATLAB code just like this, right, what is it going to do? It's going to get to this point, it's going to say, is t greater than or equal to 0? What is it going to look like? It's going to look at every single value we have in t. Are they all greater than or equal to 0? Well, no, in this case, right? We've got one that's -5. So it's going to say, that's false, right? So we can only do one value at a time when we have something like that, because not all the values are going to meet all the conditions at the same time, all right? So we say, all right, I need my for loop to help me go through all the time values, right? How am I going to write my for loop to do that? So I'm going to say for something equals something, 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 all right? What is this blank for? The index variable can be anything. Are there rules? Right, so it can't be T or A or B or C or D or M. It could be anything else in the entire world. Can't be those things, right? So what do we want to call that one? Let's make it something useful so that we remember what it is, right? So T is time, so I'm going to call it time so that I remember that I am changing time values. Because in a minute, I'm going to have rockets that are changing, and then we're going to get really confused because we've got two things changing at once. So let's make it easy on ourselves, and we're going to try to make it something that we remember what it is, right? So where in my if statement am I going to use time? My index variable. Say that again? So everywhere I have t and v, and let's think about just t. So if I have my t vector here, if I want to pull out one number from the t vector at a time, what do I have to tell MATLAB? Tart?
I have to stay the same in the column operator, or keep changing the row, like die.
Change the row or the column?
I mean the column.
The column, right? Because we have one row and we have a bunch of different columns, right? So how do I tell MATLAB to keep the row the same and change the column? One comma time. What if I decided I was going to set up my t vector and I put my apostrophe there, so now it's a row vector with one column? Time comma 1, right? So I gotta pay attention to where I put that index variable based on what type of vector I have, right? All right. So everywhere that I have t, I'm gonna stick in a 1 comma time. Figured that out. So now I know this. That should help me fill in these other 3 blanks over here. So the first time I go through my for loop, which number do I want to pull out of my t vector? The first one, which is in what row and what column? 1, 1. So that means the first time I go through my for loop, time is going to be equal to 1. So I stick a 1 here. The second time I go through my for loop, which number do I want to pull out of my t vector? The second one, row 1, comma 2. Then I go to the column 3, then I go to column 4, then I go to column 5, and I keep going all the way down, right? So that means my increment should be 1. We don't have half rows or half columns in MATLAB. We often don't skip rows and skip columns, so usually that's 1. That's a pretty safe bet. What about that last one down there? Should I put 5?
No, that's t.
Length of t. And why do I want length of t? What does that tell me? Yep.
Because I'm going to define the t as a vector.
T is a vector, and what does length give me?
The location, like for the one I calculate. Then what's
The one I want, right?
Yeah.
But what does that mean?
You can change the number of values.
Right, so that helps me be able to be flexible enough to change the number of values I have in my vector. So if I decide I want 5, or the next time I run it I want 30, or the next time I run it I want 1,000,000, then I don't have to go in my code and remember what I did before, right? So I like to use that length function so that MATLAB will tell me how many things I have in my vector so that I don't have to remember to go back and change it. Because I forget. And then it's all disasters happened. So we put our length here, and we said which variable do we want to calculate the length of? T or time? T. All right, so now we've said we need to use 1 comma time everywhere that we have t, right? So if we go in, we kind of add that in, 1 comma time, 1 comma time, 1 comma time. Where else am I going to want to use my time index variable? For the velocity. So how would I write that? Same way? 1 comma time? So I stick that in there. All right, so now what have we done so far? We've calculated velocity when we have a bunch of different time values. What do we have to do now for this problem? Change the rocket, right? So what do we think we're going to do now that we are going to change the rocket? Can we use this for loop to change the rocket? No. Why not?
Well, we need a new one.
We need a new one. Why?
Because with each rocket, you want it to go through that same iteration deal that time is doing.
Right. So we want to go to rocket 1, and then we want to go through all the time values. Then we want to say, now we're on rocket 2, go through all the time values. Then move to rocket 3, go through all the time values. What's another reason that I couldn't use this for loop to go through the rocket? How many times is this for loop going to repeat? Length of t. Is that going to be the same as the number of rockets we have? More or less? We don't know. It could end up being the same if we wanted it to be, but it's probably not going to happen. We're probably going to have more time values than we do rockets, or we could have less time values than we do rockets. We don't know, so we can't use the same for loop because this one is going to repeat how many ever times for t, but we know we only want to repeat for the 3 rockets. We have 3 rockets, we know that for sure. All right? So what are we going to need? We're going to need another for loop, right? Where do we put our for loop? Somewhere else in our code?
Above that for loop.
Above this for loop. Around this for loop. So I forgot to put my end for my first for loop. So we have our for loop, our first for loop goes around our if statements. Then I can go one step bigger and I can write my for loop for my rocket part of my problem.
Why do we have 2 ends?
So end for my ifs and end for my for, right? So now we've got to write a for loop for our rocket. What's the first thing we should do with our for loop? We got to pick an index variable. Rocket. Could it be? Should we use time? No, because we already have time. That's doing the time job. We need a new index variable to do the new job, which is to change the rocket. So we'll go ahead and call it rocket, because that makes sense. Where are we going to use rocket? Which vectors are we going to use rocket with? A, B, C, D, and M, right? They're all going to be, if we set them up, hopefully they'll all be 1 row, 3 columns, or they could all be 3 rows and 1 column, however we set them up. But they're all going to have 3 numbers in them, right? And hopefully, if we're nice to ourselves, we set them up all in the same orientation. So if I were to write this in MATLAB and tell MATLAB that I want to pull out one number out of this vector at a time, what would I tell MATLAB in my parentheses here? Rocket comma 1 or 1 comma rocket?
1 comma.
1 comma rocket. So now I go back over to my for loop and I say, the first time I run through my for loop, I want rocket to be equal to 1, because I'm going to pull out the first row, first column out of my A vector here. So I stick a 1 up here. The second time I go through my for loop, which number do I want to pull out of my A vector? 10, the second 10, right? So that's the row 1, comma, column 2. And then I want to go to row 1, column 3. So I'm going to increment by 1. Special thing you learn in this class is how to count from 1 to 2 to 3 to 4. So it's extra bonus on top of all the other things you learn. So what's our last value over there?
3.
3, or length of A. It doesn't really matter here because I didn't say it had to be flexible. I usually like to write them with the length anyway. That way if I come back in a week or whatever and I decide, now I need 5 rockets, I don't have to go change my code, right? So it's always a good idea to make your code more flexible, just in case. Just good programming practice in general. So now we've written our for loop. And what do we have to do now? We need another end. So we need another end. What else do we need to do?
Go back into your if statement and change all your A, B names to equal to 1, rocket.
Right. So if we've written a for loop and we're not using our index variable somewhere inside of our for loop, we haven't done anything really. So we need to use our index variable somewhere. So where do we put it? We put it everywhere we have an A or a B or a C or a D or an M, right?
I have a question.
Yes?
Why did you choose A and then wherever you have A or B, you will write, you use a length of A? So how about B?
Would length of A and length of B be the same thing?
It will be the same.
Doesn't matter which one you pick,
Oh.
right?
Yeah.
As long as it's going to be the same. So A and B and C and D and M all have the same number of columns, so it doesn't matter which one we pick. We don't actually use, oh, we use M. Okay. Never mind. So we have A, we have B, 1 comma rocket. We have our M up here in our if statement. We can't forget that one. We have an M in our if statement here. C. And then D. Is that everywhere I want to use a rocket? Yep.
You also need to change V to rocket coming from.
Right, so V, how many velocity values do we want to calculate? I want to calculate 1 velocity for every rocket for every time value. So if I have 5 time values, 3 rockets, I want 15 velocity values at the end of the day, right? And I want some sort of organization to them so that it's not just 15 random values, so I know what is each value. So this is where I draw myself another picture, and I say, okay, what do I want my velocity, now maybe matrix, to look like instead of just a vector? So when we had one for loop, we created kind of our output was a vector that was the same size as our input vector. When we have a nested for loop or 2 for loops, we're going to end up, as our output variables, we're going to end up creating matrices. So we're going to have matrices, they're going to have different numbers of rows, different number of columns, and that depends on how we set up our for loop. So let's draw a picture of our velocity matrix. So we're going to have a matrix. If I just had 1 rocket, I could have used 1 comma time like we had there, and that would just give me 1 row vector, right? And from left to right, I'm going to have the velocity values that match up with those time values. So across my columns, I'm changing time. And that means I'm going to have 5 columns in this case. What do we think is going to be the rows of our matrix? The rockets. So we go down our rows, and we're going to have how many rows? 3 rows, 1 for each rocket that we have. So if I look at, say, my first column that I have here, if I pull out this velocity value, which rocket is it for? Second rocket, first time value. So it would be my second rocket when time is equal to -0.5, right? What about I pull out this one down here. So this is third row, fourth column. So which rocket? Third rocket at fourth time value, which is time is equal to 10, right? So my matrix, if I draw this picture and I kind of remind myself what's in each row and each column, then it's really easy for me to know which velocity value belongs to what rocket and what time value. Okay? So now where do I, based on this picture, we said we needed to stick our rocket somewhere in with the velocity. So what do I have to change about this? Instead of having 1 comma time, what should I have here? Rocket comma time. So rocket is going to help me change my row. Time is going to help me change my column. So instead of having 1 comma time, I'm going to stick in my rocket in here. Now we've made a big mess on the board. So. Any questions about that? So you see, I don't start writing from the top to the bottom, right? I don't start with my first for loop and try to figure out how I'm going to write that rocket for loop first. I kind of go in the different layers of complexity. I start with my if statements, those are easy to write. Then I get bigger, I do 1 for loop. Then I get bigger and I do another for loop. All right, that's okay, because we're writing on paper. We're not writing MATLAB code, and MATLAB's not going to get angry with us if we're not writing things in order from top to bottom. Right? That's one of the reasons why I tell you to write on paper when you do your MATLAB translation. Otherwise, you start getting all sorts of crazy things going on in MATLAB, and MATLAB's very angry with you. Once you have this planned out on paper, you go into MATLAB, you type it all in, no problem. All right? What else do we have to do for this problem? What's task D? We got to plot some stuff, right? What do we have to plot? We have to create a plot with 1 curve for each rocket, and we're going to plot all the curves in the same figure window. What do we want to plot? We want to plot time on the x-axis and velocity for each rocket on the y-axis. So if I'm going to write my plot commands to MATLAB, how many plot commands am I going to need to create this figure? 3, right? I said 1 curve for each rocket, so 1 plot for each rocket that I have. So I'm going to have 3 plot commands. When I write my plot commands, I'm not going to write all the plotting stuff when I do my MATLAB translation. I'm going to kind of just remind myself what I need to go on the x-axis, what I need to go on the y-axis, so when I get into the code, I don't have to worry about it so much. So I have my 3 plot commands. And I want these all in the same figure window, right? So do I need subplots here, or do I need a hold on here? Hold on. So if I say multiple curves in the same figure window, then I want them all kind of on the same x and y axes, one curve right on top of the other, right? So I need a hold on. Where does my hold on go? In between what?
The plots, the first one and the second.
The first and the second?
And between the second and the third.
So you could put one here between the second and third, but you don't have to. Once you've told MATLAB to hold on once, it's good for the rest of the time, rest of the plots that you want to put on that same figure window. So you really only need one. It's not going to be wrong if you put more than one, though. So. Sometimes that's okay, but sometimes that can get into issues. So I usually do one plot and then I do it after. So what variable do I want to plot on my x-axis for my first rocket curve? Time. So which variable is that in our code? T or time? We have something called time, right? Which one? T. Why is it T? Because T is our vector that has our time values in it. Time is our index variable. It really is only used inside of our for loop. So after we've done our for loop, when we start to do our plots, we can kind of forget about these index variables. We're not going to use them. So we want to plot T on the x-axis. Do I want to plot T on the x-axis for all my rockets, or do I need to change my x-axis? Huh? All of them can do T, so we go ahead and fill that in. For my first rocket, what do I want to plot on the y-axis? Velocity. What? If I just tell MATLAB V, it's going to try to plot that whole matrix, right? What's wrong with that? There's more than one rocket in there. Plus, what are the rules about plotting? The number of points you have on your x-axis have to be the same as the number of points on your y-axis. So if I plot 5 values on my x-axis and then I have 15 values that I give MATLAB on the y-axis, it's going to be mad. So I can only give it 5 values. So what 5 values do I want to give it? Do I want to give MATLAB the first row or the first column out of my V matrix? First row. So I have my first rocket. My rockets are in my rows. So when I go to plot, I want to grab all 5 of these values in my first row and plot them in my plot command. How do I do that? How do I tell MATLAB I want all the values in the first row of a matrix?
V and then parentheses, you write the first row, and then all the columns.
And all the columns.
Yeah.
I just write that, all the columns, right? The colon, right? So colon tells MATLAB all of the somethings, right? All the rows or all the columns, I can use it either way, right? What about my second rocket? Two comma colon, and then for my third rocket, 3 comma colon. So I want to, for my second rocket, go down, pull out all the columns in the second row. Third rocket, all the columns in the third row, right? How do we feel about that?
Isn't it the same as T? The first row, first column, the same as T all the time?
The first row, first column.
No, I mean if we choose the first row, isn't it the same? The first row is T, and the second row is.
The T, why we didn't do the same, I mean.
Why didn't we do the same with T? Do we need to tell MATLAB can we plot all of T? Or do we need to tell MATLAB to plot part of T? if I tell MATLAB to plot or to display t, I type t into the command window and I tell MATLAB to display t, what's it going to print out? It's going to print out all 5 of these values, right? I don't have to tell MATLAB anything to tell it to print out just those 5 values because that's all it has, right? If I were to just type in v into the command window, it's going to print out this whole matrix. I don't want the whole matrix, I just want the first row, right? Does that make sense? So for t, I could have put 1 comma colon in there if I wanted to. That would be kind of too much overkill. All right, questions about this? So especially when we get to nested for loops, drawing the pictures and visualizing the matrices is really helpful because you start to get really confused about which is what's in the rows, what's in the columns. If you don't do it, you don't draw your pictures, I guarantee disaster. So there's lots of confusion once we get to the nested for loops. So draw the pictures. I guarantee if you come ask me about a question on your homework, come to my office, I'm going to say, where's your picture? So make sure you've drawn your pictures. All right. So now, what have we done? We've done MATLAB translation. So that took us a while, right? But what are we ready for? We're ready for step number 3, which is to actually open MATLAB and write some MATLAB code, right? And we've got our plan. We shouldn't really have to do a whole lot of thinking at this point. This step is kind of brainless. We just need to copy down what we've put on the board already, right? So what kind of program are we going to write? Are we going to write a script or a function? Script, everybody's favorite. It's mine included. I mean, I like them better too, but I make you write functions because it's good for you. All right, so what do we do at the top of our script? Housekeeping. So we'll skip our header thing. We don't need that for right now. So we'll do our housekeeping. So what housekeeping tasks do we have? Clear, CLC, and now that we've learned plotting, I'm going to throw in a third housekeeping task. And this third housekeeping task is called close all, and this closes figure windows. So then every time you run your script, you don't end up with 554 figure windows hanging around in the background. Every time you run your script, it'll close it and it'll open up new script windows for you. So you don't, or the figure windows for you, so you don't have to worry about remembering to close them. So what else? Declare our variables. So now we get to do A there, right? So we have T. So we'll just say declare the variables. We have T. We said we were going to use linspace to do that. What is my linspace command going to look like? What's my first input to linspace? -5. Second one, 16. And then how many values do I want to generate? Well, let's do more than 5. So I said you can choose a number of values as long as the curves you plot are smooth. So if I only pick 5 values, I'm probably going to get this kind of jagged looking curve. So I want to pick a good number of values a lot, maybe 50, right? And sometimes you're going to have to play around with that. If you plot something and it doesn't quite look right, then I'd add more values to it. So what else do we have to declare? We have to declare all of our other vectors for our rockets, right? So we say A is equal to 10 and 10 and 12. B is equal to 5 and 5 and 8. C is equal to 624, 624, and then 800. D is equal to 3 and 3 and 9. And then our M is equal to 8 and 12 and 8. Just forgot my square bracket. Now what?
Right, yeah. What they call it?
The code, right? The for loop. We can just start going right down here, writing our for loops out. So I'm not going to keep writing this for you. You guys can copy from the board, right? So I'll let you guys spend the last 5 minutes or so seeing if you can get some of this at least into your code. And I'll answer questions at will.